proposal for residential building. So this project focuses on designing an energy efficient MVAC system for a two-story residential house in Malaysia. Because of our hot and humid climate, it's important to keep homes cool and comfortable while using less energy. We aim to improve indoor air quality in areas like kitchens and bedrooms and provide the right cooling for bedrooms and living space. To do this, we combine two main approach, which is mechanical systems and like air conditioners and fans, and passive design strategies like reflective roof, shaded windows, and cross ventilation. These passive elements have reduced the heat. Entering the house, which means we don't need to use much electricity to cool it down. This is important because buildings use a lot of energy, especially for cooling. By choosing energy efficient equipment and using natural method to control temperature, we can reduce energy bills and environmental impact. We use AutoCAD to draw the house layout and did calculation to choose the right system for each space. Everything we plan is practical, affordable, and suitable for Malaysian homes. In the end, this project is not just about keeping a house cool, it's about designing smart, eco-friendly systems that improve comfort, save energy, and support a greener future.
In this project, we highlight why mechanical ventilation is crucial in kitchen and the bathroom. These areas produce heat, moisture, and odors, which can cause poor air quality. So, in our house design, we have one kitchen and 3 bathrooms. Each bathroom is equal to 10 meter cubic, and the kitchen is 26.25 meter cubic. These volumes help us calculate the required airflow to ensure fresh, clean air in each space. So this section explains how we calculate airflow using the air change per hour ACH method. The formula is airflow equal to room volume times ACH. For the bathroom, each one has volume of 10 meter cubic and it 10 ACH. So times by 10 is equal to 100 meter cubic per hour for each bathroom. So next, for the kitchen, it has volume of 26.25 meter cubic and it's 20 ACH due to the heat of cooking. So 26.25 times 20 is, we get 5 to 5 meter cubic per hour. So this calculation helps us to choose the right ventilation system to maintain fresh and healthy air in our house design. So for this project, we compared 2 ventilation fans from Shopee and HomePro, keeping our budget under RM250 Malaysia per unit. So the first option was silent shutter fan. It compact, quiet, and very affordable at RM25, but the airflow is only 150 meter cubic per hour, which is it's too low for our needs, so we didn't select it. So the second option is the BS Boss 12 fan, has a much higher airflow of 720 meter cubic per hour and use a more durable copper motor. It costs RM42, which is still well below our budget. Because of its better performance, we chose this fan for the bathroom and the kitchen. So this choice ensures effective ventilation without exceeding our cost limit. For the bathroom, we chose the BS Boss 12 wall fan. It is 720 meter cubic per hour, which is much more than 100 meter cubic per hour. It is strong, durable, and only costs RM42. So next, for the kitchen, we select a 12 wall for HomePro with 600 meter cubic per hour airflow. It is enough for kitchen ventilation and it is also cost RM250. Both fans are affordable, efficient, and suitable for home use.
For this project, we calculate the cooling load for 3 main areas: the ground floor bedroom, the first floor bedroom, and the combined living and dining area on the ground floor. Since the floor plan is
does not include exact dimension. We estimate room size using the standard reference such as the size of bed floor, bed and car. We assume each bedroom is about 14 square meter and the living and dining area is about 34 square meter. We also estimate the number of occupants, two people per bedroom and 5 people in the living room. Sunlight exposure was considered higher for the ground floor room because the larger window. Based on our calculation, the ground floor bedroom require about 9,250 BTU per hour, so we round it up to a 1.5 horsepower unit. The first floor bedroom is around 8,550 BTU, which is close to 1.0 horsepower. Lastly, the living and dining area requires about 23,400 BTU per hour, so we recommend a 2.5 horsepower unit. For all three spaces, we choose wall-mounted split unit air conditioner because they are suitable to resident use, energy efficient and easy to install. Each unit must also stay within our budget, a 2,500 ringgit budget. For the ground floor bedroom, we compare two inverter unit, one from Daikin and one from Panasonic. Both offer good cooling and energy saving. The Daikin model is more affordable, while the Panasonic model are air purification feature. We recommend the Daikin unit for its value is reliability. For the first floor bedroom, we compare Media and Hisense units. The Hisense model is an inverter type with a better energy efficiency and a self-cleaning feature. Although they're slightly more expensive than Media, we recommend the Hisense unit for the better long-time performance. For the living and dining area, we compare two 2.5 horsepower units. The green model is an inverter with a better efficiency but slightly over budget. The Media unit is cheaper, but it does not have inverter technology. We recommend the Gym unit if budget allows. Otherwise, Media is acceptable.
For comparison and recommendation, for all room we selected wall mount split unit air condition, which are cost effective, energy efficient and easy to install, perfect for residential application. Based on member 3, cooling load regulation, we compare to air conditioning option per space, considering performance, energy efficiency, feature and price within a 2,500 limit. So, for ground floor bedroom with 1.5 HP or 12,000 BTU per hour, we evaluate two inverter model, which is the Daikin FT KU 1.5 HP and the Panasonic X Premium 1.5 HP. Both offer excellent energy efficiency, 5-star CSPF ratings and R32 refrigerant. The Daikin model includes smart Wi-Fi control and voltage protection and is priced at around 2,339 ringgit including installation. The Panasonic models offer advanced air purification feature like Nano, TMX and Nano ET, but it is slightly over the budget at 2,798 ringgit. So my recommendation, we choose Daikin FT SKU 1.5 HP because this unit meet the cooling needs, include smart feature and fit within budget and can making it better for value option. For the second floor is first floor bedroom with 1.0 HP or 9000 BTU per hour. Here we compare the Hisense 1.0 HP inverter and the Media Glory 1.0 HP inverter. Both model provide 4-star energy efficiency, R32 refrigerant and inverter technology. The Hisense unit adds value with self-cleaning functionality and is slightly more affordable at RM1,199 compared to RM1,299 for the media unit. So for my recommendation, we choose Hisense 1.0 HP inverter because with good energy performance and self-cleaning feature, the Hisense model offer better overall value for the bedroom environment. So for the next floor, living and dining hall with 2.5 HP or 24,000 BTU per hour. For this large space, we compare the Gree Lomo 2.5 HP non-inverter and the Media Extreme Safe 2.5 HP inverter. The Gree EV unit is slightly above budget at RM2,749 but it delivers the required capacity. The Media inverter unit is more efficient but exceeds the budget at RM3,089. So our recommendation is Gree Lomo 2.5 HP non-inverter because it meets the required cooling load and is the most affordable variable option. However, if long-term energy efficiency is the priority, the media unit may be considered if budget allows.
Two effective strategies to reduce heat entering a building and improve indoor comfort using natural design methods. These strategies are reflective roofing materials and external window shading. The main objective of these strategies are to reduce heat entering the building, to lower the demand for air conditioning, and to improve indoor comfort using passive or natural design technique. The first strategy is to use reflective roofing material. This involves applying a light color or reflective roofing such as white tiles or reflective metal sheets. These materials reflect sunlight instead of absorbing heat, which is especially beneficial for upper floor directly under the roof. Benefits of this strategy include a significant reduction in roof surface temperature by 10 to 20 degrees Celsius, a lower cooling load for rooms at the top floor, improved thermal comfort, and energy cost saving in the long run. Next, we have external window shading. This strategy uses shading devices such as horizontal overhang, awning, and vertical fins or loft. These are best installed on east and west facing windows, where sunlight is most intense. The benefits are it blocks direct sunlight before it enters the house, reduces indoor heat gain and glare, helps maintain daylight and natural airflow, and improve visual comfort, which means less dependence on air conditioning. To conclude, both strategies help reduce heat transfer into the house. This leads to less reliance on air conditioning. They also promoting energy efficiency and sustainability. And the best part is there are simple low-cost improvement that provide long-term benefits. Now let me explain how the two passive cooling strategies are applied to this two-story residential house design. On the left side is the ground floor layout. You can see arrow pointing from the living room through the dining area to the kitchen. This represents natural air movement or cross ventilation. Openings such as window or ventilation panels are placed in line to allow air to flow freely through the house, helping to cool down the indoor space naturally. At the bedroom near the car garage, the window also allow air to circulate and prevent heat build up in closed space. External window shading is used on the west-facing window to block strong afternoon sunlight, while still allowing airflow. This prevents glare and heat gain while maintaining ventilation. Above the ground floor is a reflective roof, especially over the kitchen and bedroom, to minimize heat from the roof surface. On the right side is the first floor. Airflow is shown entering through the family hall and continuing to the bedroom. This creates a cross ventilation effect where fresh air can enter from one side and exit from another. With this design, warm air can rise and escape, especially if there are opening or ventilation points near the ceiling or roof. This supports stack ventilation. Another passive cooling method, reflective roofing, is again applied to reduce the amount of heat absorbed by the roof, especially important for the bedroom located directly under the roof. External shading is also used here to block intense sunlight while still letting in fresh air and daylight.
So for the conclusion, this project shows how we can combine passive and mechanical methods to create an energy efficient home by choosing the right ventilation and air conditioning system using real market data and proper calculation. We can keep the house comfortable while saving energy. We also use passive cooling strategy like shaded window and reflective roof to reduce heat from entering the house. This means we use less air conditioning, save on electricity bills, and help protect the environment. The system and design we propose are affordable and practical for typical Malaysian homes. They prove that sustainable building is not only possible but also realistic and cost effective. This project helps us apply what we learn in class to a real situation. It shows how mechanical and electrical system can work together to support green design in the construction industry. Most importantly, this project taught us that even small design choice, like where to put a window or which fan to use, it can make a big difference. As future civil engineers, it's our job to design buildings that are comfortable, affordable, and kind to environment for future